So the first thing we have to do is draw the slope fields on the indicated differential equation. What you need to do is plug in each value. So 2, let's start with this point, times, that's 0. 2 times 0 minus 1, which ends up being -1. So this is going to be a negative slope. For something like this point, it would be 2 times 0 minus 2, which is even steeper. For this point, let's do that. It would be 2 times 2 times 0 minus 1, which makes this plus. So it's 1, and it switches the other way. For this point, it's 2 times 1 minus 1, which makes this a plus. So it's 3, and it's a pretty steep slope. Then we have 2 times, for this point, it's 1 minus 1, and that's positive 1. Okay, so it's a regular slope. For this point, you have 2 times 1 minus 2. That becomes 0, and it's a 0 slope. So the first thing we have to do is draw the slope fields on the indicated differential equation. What you need to do is plug in each value. So 2, let's start with this point, times, that's 0. 2 times 0 minus 1, which ends up being -1. So this is going to be a negative slope. For something like this point, it would be 2 times 0 minus 2, which is even steeper. For this point, let's do that. It would be 2 times 2 times 0 minus 1, which makes this plus. So it's 1, and it switches the other way. For this point, it's 2 times 1 minus 1, which makes this a plus. So it's 3, and it's a pretty steep slope. Then we have 2 times, for this point, it's 1 minus 1, and that's positive 1. Okay, so it's a regular slope. For this point, you have 2 times 1 minus 2. That becomes 0, and it's a 0 slope. So as you know by this point, the second derivative determines concavity. Part B is asking us to find the concavity in quadrant 2. So because this is quadrant 2, we have to find the first derivative and then the second derivative. It already tells us the first derivative is 2xy. So to find 2x minus y. So to find the second derivative, we take the second derivative. So we have 2 minus y prime. However, they tell us y prime is 2x minus y. So we can imply that it's 2 minus 2x minus y. Okay? In order to find numbers from the second quadrant, we can just extend this over and add on some points. So we can put -2. And then we'll find it for this point, and this point, and this point, and this point. So what we can do is 2 minus, we can start off with this point. We can say 2 minus 2 times -1 minus y at that point, which is -1. We can turn this into a positive. We can say 2 minus -2 plus 1. Then this becomes -1, 2 minus 1. This is a positive number. The number itself doesn't really matter, we're just looking for the sign. So we can say that this is concave up. Now we can test another point just to make sure. 2 minus 2 times -2 minus 2, but this eventually becomes plus. So this is -4 plus 2, which is -2. And we have 2 minus this. This becomes plus, and it's equal to positive. So this point is also concave up. So we can determine that quadrant 2 is concave up. So this question is asking us to find whether this differential equation gives us a maximum, a minimum, or neither. And it tells us that x is equal to 2, and when y is equal to 2, that and when x is equal to 2, that y is 3. So based on our initial condition, we're going to plug these numbers in. Or actually, we're going to set it equal to 0. So 0 equal to 2x minus y. And then we're going to plug it in. 2 times 2 minus 3. This is going to be 4 minus 3. 4 minus 3 is equal to 1. And then we just go ahead and bring this 0 down. Basic math tells us that 0 is not equal to 1, so we can say neither. So they're asking us to find m and b in constant form, but they've given us a differential equation and wanted in this. So what we can do is we can find the derivative of this. So we can say y prime, because they're saying m is a constant, we can assume that that's the derivative of mx. And because b is also a constant, we can then assume that the derivative is 0. So what we're going to do is we're then going to plug in dy dx is equal, or we're going to put in a different notation. So dy over dx is equal to m. We can now set m equal to 2x minus y. Now, because we know that y is equal to mx plus b, just to get rid of a y and make the variables more concentrated, we can say m is equal to 2x minus mx plus b. Now we can distribute and go 2x minus mx minus b. If you're looking at what I'm looking at, I'd factor out an x, put 2 minus m minus b. We can set this all equal to m. Now, in order to make this side look like this side and make it look just a bit easier, we can do 0x plus m is equal to x, 2 minus m minus b. And then we can assume that this is equal to this, and this is equal to this. So we're pretty much saying that 0 is equal to 2 minus m, and m is equal to negative b. So we can then assume that this implies m is equal to 2, and that b is equal to negative 2.